Okay, hello everyone. In this video, I'm going to be talking about refraction of sound waves and other properties of waves. In the previous video, we saw reflection. So here we are going to look at refraction, diffraction, interference, and beats. Okay. Now, refraction of sound waves is a phenomenon whereby sound travels from one medium to another. Refraction is actually a property of wave where you have two medium. Let's assume this is a medium 1 and you have another medium 2. So and this is a normal line. Okay, now the refraction, whenever sound wave comes from afar, there will be a bending. So refraction is a bending or a change in direction of sound as it travels from one medium to another. Now I like to say this, that when waves travel from one medium to another, the following things changes. The speed changes. So there will always be a change of speed whenever a wave travel from one medium to another. Again, there will be a change in wavelength. Very important. So wavelength also changes, and there will be a change in direction. So these three things changes whenever a wave is traveling from one medium to another. And I will also like to note here, very importantly, it's important to note that frequency does not change. So the frequency of a wave does not change as it travels from one medium to another. That is very, very important. Now, what is the implication of refraction of sound waves? Now, refraction of sound waves is the reason why sound from afar is heard clearly in the morning time, in the night time, than in the daytime. And there is a reason for this. In the daytime, the air below, close to the surface of the earth, that's in the daytime, is hotter, and while the air above is colder. So the colder is denser, the hotter is less dense. And there is something that you should know, that whenever a wave is traveling from a denser medium to a less dense medium, the wave moves away from the normal. The distance from the normal becomes too wide. It bends away from the normal line. That means have a very large refractive index. And that is why it is very difficult to hear a sound in the daytime. This is the reason, refraction of sound. Now, in the case of in the night time, this is day, and now this is night. In the night time, whenever sound is coming from afar, in the night time, the air close to the earth is cooler. Okay, and cooler means it is denser, and while the air above the earth is hotter, hotter simply means that it is less dense. Now you experience something, that once a sound wave travels from a hotter medium, a less dense medium, to a denser medium, it refracts towards the normal. It is closer to the normal. This is the normal line. We call this the normal line. It is closer to the normal, and so that is why you can hear sound very clearly in the daytime, in the night time, than in the daytime. This is very, very important for you to note. Now that leads us to diffraction of sound. Now diffraction is the bending of sound around an obstacle. Okay, there was something we usually teach then. Let's assume you have a little space here and you have a wave coming this way, and once it passes through this little obstruction, it's going to bend. Okay, this is what we call diffraction. Now, diffraction of sound, this is important for you to know. Diffraction of sound is the reason why people in different rooms that don't see each other can hear something going on in the other room. For those that like gossip, you can hear what is going on in another room, and the reason is because of diffraction. So somebody here can observe and hear what is going on inside here, the sound produced from inside here, because of diffraction. That is very, very important for you to note. and that is an exam worthy question. Now, the next property of sound we are going to talk about is interference. Now, interference is simply when two sounds combine together, or when two waves combine together. You know, two waves from the same source, they must come from the same source, and not only that they come from the same source, they must have the same frequency, they must also have the same wavelength, they must also have the same phase. Very important. So when two waves having the same source, the same frequency, the same wavelength, and the same wave come together, they can produce their coming together can actually give a resultant wave that is higher, maybe a high sound, or a resultant wave that is lower, or a low sound. We know that there are two types of interferences. We have one is called constructive, and we have the other that is called destructive. Now, the constructive interference is such that the two waves, crest overlaps crest and troughs overlap trough, like this. You see this? These are two different waves. This is wave 1 and this is wave 2. Both of them come together. You can see they meet at this point and they meet at this point. This is a constructive interference. The reason why it is constructive is that when these two waves combine, you are going to produce a wave of a greater amplitude, like what I have here. So the combination of two waves produces a bigger wave. That means the sound, you are going to hear a louder sound that is greater than the sound of the individual waves that are combined. In the case of destructive interference, the crest of one wave, this is what we call crest. This is a trough. So the crest of one wave overlaps the trough of the other waves, like this. This is a trough. Okay, and because of this, the resultant, they cancel each other. The both of them cancel each other. So at that region, there is no sound. No form of sound is heard because one wave has cancelled the other. That is interference of sound. It is also another important property of sound waves. Now, another important property of sound wave are what we call beats. Now, beats are like interference, but not exactly. It is when two waves of slightly different frequency superimpose each other, such that the way the two waves cancel each other is equal to the difference between them. So the frequency of one is slightly different from the frequency of the other. Are you getting what I'm saying? And that is what gives rise to what we call beat frequency. Now, and beat frequency is simply F2 minus F1. That means the frequency of one of the wave, the bigger one, the wave with the higher frequency, and the frequency of the lower wave, the wave with the lower frequency. Now, that is very, 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 very important. Okay? So the two waves either reinforce or cancels each other, but whatever the effect, it is equal to the difference between the frequencies of the wave. Now, I have a question here I like us to go through. This question says two tuning forks produces sound of frequency 512 hertz and 516 hertz respectively. Okay, and it says calculate the beat frequency. Now, I've also seen in an exam case where you are asked to calculate the beat period, So the beat frequency is very simple. It's 516 minus 512, F2 minus F1, and that will give you 4 hertz. That's quite easy. If you're asked to find the beat period, the bit period will simply be equal to 1 over the bit frequency, which is 1 over 4, which is going to be 0.25 seconds. It's very important that you note this and observe this. Very, very, very important. Okay, so bits are used in, to tune musical instruments, and all of that. Is quite an interesting property. So that is it for that one. Now, the last property I'm going to quickly talk about is what we call Doppler effect. Now, but I'm not going to say much here because it is beyond the scope of this particular lecture. For undergraduates, I can produce a video on Doppler effect for that. Now, but for now, we are just going to see the definition for Doppler effect. Doppler effect is simply the relative change in the frequency of sound, okay, due to a relative motion between an object or an observer and a source of sound. Now, what that means is that because the source of sound and an observer are in relative motion, okay, the frequency of sound may change apparently, not actual but apparently. A very good example is when you hear let's say you hear music from afar. It's going to be faint, but as you keep walking towards that music, as you keep trekking, walking towards that music, you notice that the sound starts becoming clearer. That effect is what we call Doppler effect, and it has some calculations behind it. But for now, all you need to know is the definition for Doppler effect. Okay, thank you very much. Watch out for the next video after this. Thank you.